corresponding parts and scale factors. So today we're going to be looking at describing features of scaled copies. Our ICANs are I can describe what the scale factor has to do with the figure and its scaled copy. In pairs of figures, I can identify corresponding points, corresponding segments, and corresponding angles. So make sure you've got today's date, your ICANs, page number, and you're ready to move on. So first thing is we're going to go through and do a little bit of a number talk by working through some unit fractions. So let's see if you can come up with these mentally. So what's 1/4 times 32? Should be 8, right? Because it would be 32 over 1, and then you have 32 times 1 is 32, 4 times 1 is 4, 32 divided by 4 is 8. What about 7 2/10 times 1/9? Well, isn't that 7 2/10 same as 72 tenths? And we divide it by, or multiply it by 1/9. We get 72 90ths, which you can divide 9 out of both of those, which is going to give us 8 tenths. What about this one? 1/4 times 5 6/10. Again, 56 tenths, because it'd be 5 6/10, but you make it into an improper fraction, makes it a little simpler to solve out. 4 will go into 56, let's see, what, 14 times. So we divide both those out by 4. We end up with 14 tenths, which is the same as 1 4/10. Okay, not too bad. All right, let's do a little deeper. So you're going to have all these to take a look through and test out on your own. In fact, one moment. So you'll have a link that'll take you over to this. So you got a road sign for a railroad crossing is a circle with a large X in the middle of 2 R's on the sides. Here's a picture of some points labeled and 2 copies of the picture. So here's the original picture. There's 1 copy 1, copy 2. And you've got a tool here that if you click the move button, you can bring it into wherever you want. And then you can turn to check to see if it's the same angles. So you can see on this one here that I've got those angles like this. So you're going to interact with this and see what you find out. And compare and see if either of these are a scaled copy or not. Okay, so if you've done this correctly, this piece here should just fit in and you should be able to use to test. So if I put that point right on the E, and then I move this over here, that's the same exact angle. If I move it over here, same exact angle. Well, it would help if I moved it in the right spot. So looks like number 1 is a copy. What about number 2? Yeah, look, if I line up one part of this angle with it here, you can see that it clearly doesn't match the angles that I've got here and here. And if I take and I move this down to this bottom part here and look at angle XYZ, you can see that it's the same sort of thing. It's significantly different. So that means that this one is not a copy. So you just need to finish out this table by looking at what is up here that matches down for the same thing. So in original, point L is the same as, point B in copy 1 and point V in copy 2. So you'll just type in those pieces of information. Okay. Same thing with each of the line segments, just to help you visualize where everything is going. Okay. And then we just talked about how scaled copy compares to the original, that the only scaled copy here is number 1 because it has all the same angles to it, which would lead us to believe that it's the same shape, just a different size. When you're going to go through this page, you're going to see that there's a lot of other question pieces on it as well. Okay. They use the same thing, it's just talking about these other parts. And this is what we just talked about a moment ago. Angle NOP corresponds with which angles here? Well, it's an exact match for DEF, right? Corresponding angle in copy 2 is XYZ, but again, it is not the same angle, but it should be the same angle if it was a scaled copy. Okay, now I'm going to have you do the same sort of thing with triangles. So on that same page that you were just on, you should be able to scroll down a little bit and see this next part. And you need to determine which of, if any of these, are scaled copies of O. And decide which ones are not scale copies. So which ones are scale copies and which ones aren't? Well, I think we can tell the ones that aren't pretty quickly, right? Yeah, so O has a right angle. A, these not have right angles? Yeah, so A is not one of them, definitely. F is not one of them. And I think that's it for those. Okay. We can tell those right away because they don't have a right angle, which this has a right angle, so those would have to match as far as that. Now, does that mean that all the rest of these are a match for it? No, because now we got to look at the ratio of the parts. So we've got a 4, 5, and 3. So we have to make sure that all the parts have the same sort of ratio with them to make them work. So does B work? Yeah, B is an exact copy, isn't it? What about C? This one's not going to work because look, we have 4 here, we have 5, we have 3 here, we have 2, we have 5, we have 5 and 39 hundredths. So while this one's getting bigger and this one's getting bigger, this one got smaller, and that's not going to work. That's not going to give us our scale copy. What about D? We go from 4 to 2, that would be divided by 2. 5 divided by 2, would that be 5 halves? 3 divided by 2, would that be 3 halves? Yeah, that would work. So D would work. Okay, on roll here. Let's see, what about H? 4 divided by 2 is 2. 3 divided by 2 is not 2. And 5 divided by 2 is not 2 and 83 hundredths. So that's not the same. Okay. What about E? Yeah, E works because, look, we have each one of those is just doubled, right? So we have 8, we have 10, we have 6 here across the bottom. So all of those would work as well. Okay. Let's see, what about G? Well, let's see here. Well, we have 8 thirds, we have 2, and we have 10 thirds. Is that going to work with any of this? Kind of looks like we're taking whatever is here and multiplying it by 2 thirds. Yeah, because 4 times 2 thirds would give us 8 thirds, right? 5 times 2 thirds would give us 10 thirds. Would 2 thirds times 3 give us 2? Well, yeah, because it would have been 6/3, right? 6 divided by 3 is 2, so even G works. So when we're looking at these scale copies, we can use angles to help us right away figure things out, but then we have to look at our other pieces to help ensure. So how do we know that the ones that we found were the same? In other words, how do we know that they corresponded? Well, we had to look at the same parts of the shapes, right? So we had to look at our height here, and look at the height, look at the height, look at the height, look at the height, and compare the height. We also had to look to see if it was at a right angle. But then we also had to look at our base on all of them. And again, we had to look and see if those were proportional, that we were moving with the same kind of rate to make that scaled copy, that we're using the same factor to scale it up or scale it down. And then the same thing with the final part here, the hypotenuse, this angle that, or the line that goes across here. It's the longest part of the triangle, in this situation at least. So we had to use that to help us determine if it was actually a scaled copy or not. So what do we mean by corresponding parts? Well, when we talk about corresponding parts, we're looking at the things that are in the same position or the same part of the shape used the same way. For example, here where we have the 6, line AC, the corresponding part for that is DF, right? Because it is that same part of the shape, and it also has the same opposite angle. Because if you look, this angle appears to be the same. Now, we could obviously measure it to find out for sure. So corresponding parts means that we're just looking for the things that are working together to show the new thing. And in a scaled copy, you're going to be able to go from one to the other by either multiplying or dividing by a number. And then that same number should work on the other parts as well as they transition from their corresponding piece. So it's just like what we talked about with ratios, in that when you talk about a ratio is comparing things to each other, but then you can make equivalent ratios by doubling or dividing in half or multiplying by 10 or dividing by 15, whatever it is that you're using the same pieces to make it work. So how does a scale factor work? Well, again, it's one of those things which you're looking at something that you are either multiplying by, or if you're going from a bigger to a smaller, that you're dividing by, that works on all the pieces to make them work. Now, it's not adding or subtracting, it's multiplying or dividing. So like here, we've got 6 going to 9. What's the scale factor here? What do you have to multiply 6 by to make 9? Well, if you multiply 6 by 1, you get 6, but you still need 3. Is there a way to multiply 6 by something to get 3? Yeah, half. So actually on this one, it's multiplying by 1.5, or 1 5/10. If I multiply 4 times 1.5, or 1 5/10, does that make 6? Yeah, 4 times 1 is 4. 4 times 5 is 20 tenths. So 2 whole plus 4 gives us 6. Same with the 5 times 1 5/10. It still gives us a 7 5/10. So the scale factor here is multiplying by 1.5. Or if we were going from, that's going from this way over. If I'm going back from the larger to the smaller, yeah, I have to divide. So the situation just changes depending on what you need for that situation. So we identified corresponding points. We talked about how those match up on things, corresponding segments, and corresponding angles, and how those work together to help us find the scale factors, whether they are actually a scaled copy. So we are all set for today.